Remote learning experience. Today is going to be a lesson for Monday, which is going to be some date. Let me check real quick. Monday is going to be the 30th. Okay, so we're almost done with March. So yeah. So I'm sure you guys have heard by now that our remote learning experience is going to continue until May 4th. Just because of everything that's been going on. I'm sure you've heard about that. So I'm definitely here for you guys in this time. I know this can be really difficult, but I also think that we can make it work. At the end of this lesson, I'm going to talk to you guys about some of the office hours that I'm going to be offering through Zoom where you can ask questions and everything. So yeah, but we're just going to keep moving along and get through what we need to get through. So last week we were discussing formula and formula mass. So a lot of that had to do with counting atoms and then adding up masses based on the periodic table. And this is kind of along the same lines, except this week we're talking about percent composition. Okay? So percent composition is the percentage by mass of each element in a compound. Okay? So all that really tells you is how much mass a particular element makes up in a compound. So, for example, in this compound, this is silver sulfide. So there's 2 atoms of silver and 1 atom of sulfur. And by looking at this right here, this has already been pre-calculated, and we're actually going to go over how to do this. But all this means is that 87.06% of this compound is made up of silver, and 12.94% of this compound is made up of sulfur. Okay? So that means that if you were to have 100 grams of silver sulfide, 87.6 grams of that would be silver, and 12.94 grams of that would be sulfur. So you can kind of think of percent composition. I guess I would compare it to like maybe a sandwich. So, for example, if I had a peanut butter and jelly sandwich or whatever sandwich that you really prefer, especially if you're allergic to peanut butter, maybe you really like peanut butter. So, 60% of the mass of that sandwich is going to be peanut butter. And then the rest of the percentage, aka that 40%, would be jelly. Or if you're like, I'm not really a big fan of peanut butter, maybe it's 30% peanut butter, 70% jelly. I don't know. I don't know how you eat your sandwiches. But that's kind of how I like to think of percent composition. It's just kind of thinking about a part of a whole. Okay? So, percent composition is used to kind of determine how much of an element can be produced from a given mass of a compound. Okay, so this is actually pretty important for manufacturing, so determine how much of something can be produced. Okay, and then it's also used to calculate how much of an element is needed to make a compound. Okay, so these are kind of 2 applications of percent composition, maybe how they're used in manufacturing or how a chemist would just use them in their everyday kind of life. So we're going to talk about how to find percent composition and also go over some examples together. So all you have to do today is watch this video, and then I'm going to give you guys some practice problems to do on your own tomorrow. So make sure that you guys are taking notes on this lesson because this is going to be important for you to reference once you do those practice problems. Okay? So this is kind of my 3-year-old handwriting, but bear with me. So this is how to calculate percent composition. Okay? So before I talk about this, I want to get into a quick story because I know you guys love my stories. So I'm sure if you guys have been watching this, it's been super painful to watch because whenever I try to draw on this with just my mouse, it's incredibly painful. I don't have an Apple Pencil like some people, so it's been really hard, but I recently got this tablet from Mr. French, if you guys know Mr. French, and it allows me to kind of draw from the tablet onto my computer screen, so I can do like, oh crap, hang on, I have to click the draw icon right there. I can kind of move my mouse around like this. Look how fluid that is. I can draw pictures more easily. Look at that. Before, it was like a struggle, and I was like drawing things like this, but now we went from this to this. So you guys should expect higher quality from now on. Anyways, back to percent composition. So the way that we find percent composition is, like I explained before, it's kind of like it's a part of a whole, okay? So you take whatever the mass of an element is in a compound, comp for short, and you divide it by the total mass of the compound, okay? And then you take whatever that happens to be and you multiply that. Oh crap, that wasn't very good. You multiply that by 100. Okay? So with the peanut butter and jelly sandwich example, if I had a sandwich that the whole sandwich together, so that would be the total mass, weighed 12 grams. And the peanut butter, if I wanted you to find the percent composition of the peanut butter, you would take however much the peanut butter weighs, divide it by the total mass of the sandwich, multiply it by 100, and there's your percent composition for your peanut butter and jelly sandwich. So I highly recommend you use this technique when you make peanut butter and jelly sandwiches from now on, and you can impress all your friends and your family. So just saying. All right, so I want to go over a couple examples because this can be a little bit tricky. But first, I need to pull up the periodic table. Periodic table. Right here, this has been my favorite one recently, the dynamic periodic table. It has such a cool name, and it's a cool periodic table. So this is kind of like last week when we were using the periodic table. You're going to want to refer to the mass of the element, which can be found right under the symbol. So if I was looking at aluminum, its mass would be 26.982. Okay? So back to this example, I have silver and I have sulfur. Okay? So I'm going to write down those, and I'm also going to write down how many of each that I have. Okay? So I have silver right here, and then I have sulfur right here. See, look how easy that was. You thought this was going to be painful, but it's not. Okay? First, I'm going to figure out how many atoms of each that I have. So if I look at my formula right here, I have 2 atoms of silver, so I'm just going to put a 2 right here. And then I just have 1 atom of sulfur, just like that. All right? So kind of similar to last week, I'm going to multiply however many atoms I have by the element's mass. So if I have 2 atoms of silver, I'm going to look at the periodic table, go to Ag, which is right here, 107.87. Okay? So I'm going to put 107.8. Didn't register. Hang on a sec. 107.87, just like that. All right? And I'm going to multiply those two together, right, to find out how much total mass of silver that I have. All right, but first I'm also going to find the mass of sulfur, which if I look here happens to be 32.06. So I'm going to write that down really quick. 32.06. All right, let me get a calculator very quickly. Got my phone, which will serve as my calculator. All right, so if I do 2 times 107.87, I get 215.74. 215.74. Just like that. And then obviously I just have 1 times 32.06, which is 32.06. just like that, okay? So now I kind of have the parts of the whole, all right? So there's a part right here, and there's a part right here, okay? Part of this compound is made up of silver, part of this compound is made up of sulfur, okay? But I also need to find the total mass of this compound, okay? So I have my parts, but I need to find out what the whole is. So I'm gonna add these together to find the total mass, kind of like what you did for molar mass and formula mass last week. This is gonna be the same exact thing. You're just gonna add them together, all right? So 215.74 plus 32.06 equals 247.8. Just like that, okay? And my units here for percent composition are gonna be grams. Okay, so I'm just gonna put grams right there. Okay, no need to use AMU. We're gonna use grams this time, okay? So now I'm gonna find the percent composition of both silver and sulfur, okay? I know that I already gave you guys what the percent composition is, but now we'll be able to actually calculate it and see what it means, okay? So remember, if I go back to the slide before this, all right, the percent composition is the mass of an element in a compound divided by the total mass of the compound, okay? So if I wanted to find the percent composition of silver, I would take its mass, its total mass in the compound, which is 215.74 grams, and I'm going to divide that by the total mass of the compound, which is 247.8 grams. All right. So I'm going to do that on my calculator very quick. Divided by 247.8, and I get 87.06, which is what I got earlier too, so that's good. Oh, crap. Okay, so that tells me that of the total mass of this compound, 87.06% of it is silver. Okay, so the majority of the compound by mass is silver. Okay, so now I'm going to do the same thing down here, but for sulfur. So I'm going to take the part of sulfur, which is 32.06, and I'm going to divide it by the whole, which is, again, 247. 0.8 grams. No, stop doing that. Okay. Get on my calculator very quick. Divided by 247.8, and I get, oh, and then multiply that by 100. Don't forget to do that. 12.9, about 12.94. I rounded up. So 12.94% of this compound by mass is silver. Don't forget to multiply by 100. Okay, and that'll give you your percent. All right, so make sure that at the end of your problems that these two numbers, all right, will equal 100%. Okay, so 87.06 plus 12.94 is 100%, so I'm all good with that. Okay, so that would be a good idea to do, is just to make sure that your percentages add up to 100. Okay, so that is example number 1. So I have 2 more examples. This is going to be very similar to the one I just did, and then this one is a little bit more tricky. So I recommend that you stick around, but if you feel like you got this part of it, or this part of it, you can kind of skip ahead to this part, but I'm going to do this one just in case. Okay? So I have 3 elements in this compound, all right? This is sodium carbonate. Okay, so I have sodium, carbon, and oxygen. So I'm just going to list down whatever elements that I have. Sodium, carbon, oxygen, right? And I'm going to count how many atoms I have of each. So I have sorry, I cannot answer that right now. All right. It's probably just YouTube wanting me to become verified or something. All right, so I'm going to count how many atoms I have of each element. So right here I have 2, atoms of sodium. All right, 1 atom of carbon, and 3 atoms of oxygen, okay? Then I'm going to make sure I find the mass of each one of these using the periodic table. For sodium, it happens to be 22.99. Just try to keep it to 2 decimal places. Carbon, pretty sure is 12.01. Yep, 12.01. And then oxygen is, I'm going to round up to 16. All right, I should have done that with sodium, but I didn't. Say 16.000. Okay, so I'm going to do some quick calculations. So 22.99 times 2 is 45.98. This obviously times 1 is 12.01. And then 3 times 16, should be able to do that in my head, 48. Perfect. These are all going to be in grams. Right? So these are the parts, okay? So that means of this whole compound, 45.98 grams of it are sodium, because remember there's 2 atoms of sodium, not just 1. 12.01 grams of this compound is carbon, and 48 grams of this compound is oxygen, okay? So I found the parts, now I'm going to find the whole by adding these all together. So plus 12.01 plus 45.98 is 105.99. I'm actually just going to round up to 106. Whoa. Just like that. All right, so this is the whole right here, and these are the parts of the whole, okay? So now I'm going to find the percent composition of each of the elements in the compound, okay? Starting with sodium. So I'm going to do however much the mass of sodium is in the compound, which happens to be 45.98 grams. Right, and I'm going to divide that by the total, which is 106.00 grams. Why is this lagging? Grams. Okay, so I'm going to do that, multiply the whole thing by 100, and what I get is 45.98 divided by 106 is 40, multiply that by 100, 43.38, okay, percent. So that means by mass, sodium makes up 43.38% of sodium carbonate. So that's a pretty good amount. Now I'm going to move on to carbon, which is going to be 12.01 grams. Divide that by the total, which is 106. And then multiply that whole thing. Why do you do this to me? By 100. Okay, when I do that, 12.01 divided by 106 times 100, I get 11.33. gosh, this thing is being stupid. 0.33%. Last but certainly not least is oxygen. All right, that's going to be 48 divided by grams. 106 times 100. And I'm going to get 48 divided by 106 is 45.28. Okay, so that means 43.38% of this compound by mass is sodium, 11.33% of this compound by mass is carbon, and 45.28% of this compound by mass is oxygen. So I'm going to add those three values real quick just to make sure that they equal 100 or almost 100 plus 11.3 plus 45.28. So it equals 99.99. So that's okay if it's off by like 0.01 or 0.02, just as long as it's like 99 or greater. Make sure it's not like 95. Okay, then you've definitely missed a step. All right, it might not equal 100 every time, just when you do some rounding like I did, which is fine. Just make sure that you double check yourself. Okay, so that would be how to do this one. All right, so I'm going to do one more example for today. All right, then just talk about a couple of housekeeping items, and then that's going to be it for you. All right, so this last one is a little bit more tricky. It's more of a word problem. So the question is, a compound consists of 1.967 grams of sodium and 3.033 grams of chlorine, I mean. Calculate its percent composition. So that means we have salt or sodium chloride on our hands, okay? And the sodium makes up 1.967 grams of that salt, and the chlorine makes up 3.033 grams of the salt, okay? So now we need to calculate its percent composition. So we already know how many grams of each that there are, so in this case, we don't have to look at the periodic table, okay? So if it gives you the values for each of the elements in grams, that means you don't have to look at the periodic table, okay? You're just going to look here and then use these values, okay? So that means that I have one atom of sodium, one atom of chlorine, all right? But first, now that I have the parts, okay, these are the parts right here, I need to find the whole. So what I'm going to do is I'm going to add those together really quick. So I'm going to do 1.967 grams plus 3. Goodness me, 0.033 grams, okay? And that's going to tell me what the total mass of the compound is. Oh my goodness. So 1.967 plus 3.033 is 5, okay? This is 5.00 grams of sodium chloride or salt, okay? So now that I have the whole, all right, I'm going to find my percent composition for each of the elements, okay? So I have sodium, and the part of the compound that makes up sodium, or that makes up sodium chloride, is 1.967. Sometimes this thing lags. Grams. And then the whole is 5. All right? And then I'm going to multiply that by 100 to get my percent. And when I take 1.967 and divide it by 5, and then multiply that by 100, I get 39 39.34%. Okay, so that means in this particular sample of sodium chloride, 39.34% of it is made up of sodium by mass. Okay, so I'm going to do the same thing for chlorine. So the mass of chlorine in this case is 0.033 grams. Divide that by 5.00 grams. All right, multiply that by 100. Okay, so I'm going to do 3.033 divided by 5, multiply by 100, and I get 60.66%. Okay, so if I add those two values together really quick, just to double check myself, make sure it equals 100, 39.34 plus 60.66. Wait a second, I did that wrong. 39.34 plus 60.66 is 100. First when I did that, I did it wrong and I got like 120 and I was like, whoops, did that wrong. All right, so that means that this would be correct. All right, this would be part of my answer. And this would be the other part of my answer. Sometimes I might only ask you for the percent composition of one element or the other, but in this case, you need to do both. Okay? So that is going to kind of wrap up the content part of our lesson, but I just want to move on to a few housekeeping items, so please stick around. I'll try to make this as brief as possible. All right, so I want to do a brief recap of your assessment and your quiz, okay? So your assessment is put into PowerSchool. Everyone should have a grade who took the assessment. If you have not taken the assessment, you need to make a plan with me ASAP because I do not want you to get behind, okay? This was a competency assignment, okay? There were 2 competencies attached to this assessment. All right, so if you got a 1 on either of them, you're going to need to revise it and correct it somehow because we need you to be passing competency, okay? So if you happen to get a 1 or you would like to make test corrections, I'm fine with that, but I'm going to hand back your test tomorrow and I need your corrections by, you'll get your test today and I need them corrected by 11:59, okay? And then your actual makeup for the test is going to be due on Tuesday by 11:59. Actually, I feel like I may change that. I'll let you know. But corrections, the test is going to be given back to you today. You need to correct them by 11:59. Okay, you don't have any practice problems to do today, so please get that done. And then your actual retest will be due tomorrow at 11:59 p.m. Okay, so we need to get you made up, get those competencies remediated, and move on with our lives. All right. Quiz. Some of you have not taken the quiz either, but your grades are posted. And I also made comments in PowerSchool Learning, okay? So there's a little comment box, and that lets you know what you did wrong if you got some points off. And if you would like to revise it, you can absolutely do that. But I need it revised and handed in by tonight at 11:59 p.m., okay? So since you don't have any practice problems to do, I would definitely focus on these 2 things, either making up your assessment if you need to, or making up your quiz if you need to, okay? So those are what I have in store for you tonight, if that applies to you. If you have any questions, please feel free to just ask me, all right? And last but certainly not least is on Tuesdays from now on, I'm going to be offering office hours for you guys through Zoom, okay? So, oh, shoot. So this is going to be through Zoom. Smiley face right here. Okay, so you will be able to access my help face-to-face from 1 to 2 p.m. on Tuesdays. Okay, please take this seriously. Obviously, I love to check in with you guys and see how you're doing and joke around here and there, but I also want to give time to those who really have questions about the content that we're covering. okay? So if you just want to say hi real quick, that's fine. But if you decide to goof off and not take it seriously, I might have to remove you from the Zoom, okay? So please come with questions if you have any. These are going to be from Tuesdays from 1 p.m. to 2 p.m. I will just be on Zoom and you can join it if you want. If you don't care and you don't want to see my face, I'll probably cry a little bit, but it'll be all right. We'll all be okay in the end, okay? So this is going to wrap up today's lesson on percent composition. Hope you guys have a great rest of your day, and please feel free to email me with any questions.